Hello, welcome to the final spiral in the 1P course. And I can hear the crowd going wild with cheers. All right, we are in the fifth and final spiral, so things are just kind of knot up or tie up for us neatly here. So the first lesson in Unit 5, or Spiral 5, is determining the values in linear relations. So I'm going to take you through a couple of examples. You guys have all the base knowledge. Now we're just kind of tying things all together. So the first example, rental car costs $50 per day and an additional 20 cents for every kilometer you drive. So the first question is, what is the dependent variable? So remember, we have two types of variables. We have independent, can't spell it, try that one more time. Independent, and down a little bit more, we'll go dependent. All right. Okay, so dependent variable, independent, okay, this is what you can control. I keep it simple. You can control, all right? Whereas dependent, you cannot control. So it depends on what happens, all right? So in this situation, when we're looking at answering part A, and we're going to do it right, we'll put the A right here under the table. What is the dependent variable? So the two variables are number of kilometers and the cost. So ask yourself, what can you control? Can you control how far you drive? Or can you control the cost? So in this case, if you're talking about driving a car, you can control how far you drive. You can say, oh, I'm going to drive 20 kilometers, I'm going to drive 30 kilometers. The cost depends on that. So in this case, it is your, oops, sorry, they want the dependent. So dependent variable is cost. The other way to remember this, okay, the independent variable is always x, and your dependent variable is always y. All right, so there's question A taken care of down below. Make a table of values for the rental fee up to 1,000. Okay, so here we go. I'm not going to go up to 1,000. Let's go up to 500. That's just because that's the amount of space they gave us. We have to fill in the y values. If I don't drive the car anywhere, it's going to cost me $50. Now I have to pay 20 cents for each kilometer. So that means 20 cents, 0.2 times 100. You go through and you do that calculation. All right, so 100 times the 0.2 gives you 20, but you had to pay that $50 originally, so every time we're going to increase by $20. So instead of putting it there, all right, it's going to be 50 plus 20, which means it's 70. And every time we drive 100 kilometers, so 0.2 times 100 is $20. It's going up by 20, so 50, 70, 90, 110, 130, 150. So this is a very expensive car. It must be a really nice car to cost that much. So there's our graph. Now, or there's our table. So now we want to graph it. So at 0.50, so it's right here in between. Maybe I'll pick a different color so it's easier for you to see. Let's go with blue. 0.50, 100, 70, 290. Of course, that's to be in the middle of each one for us. 300, 110, 2, and now I can start seeing the pattern. Ask myself, is this linear? Why, yes, it is linear. So that means that we can put a line of best fit. So I'm going to grab my ruler and I draw my line of best fit through the entire graph here. And there we go. All right. Now, part D below says write the equation. Remember, the equation is always y equals rate of change times x plus the initial value. What is our initial value? Initial value is where the graph crosses the y-axis. So that means the initial value is 50, or it's when 0 occurs in the table of values, so 0.50. Our rate of change, it's nice because we did a table of values. So we know the rate of change is 20. If I didn't have that, I would have to draw a triangle, all right, and say, oh, this is 300, and it went up, whatever, all right. But because we have the rate of change, oh, we got to be careful because the rate of change isn't just the table of values, is it? No, you're thinking to yourself, well, that doesn't make any sense. We know what the rate of change is. It was given in the question. Right here. Right there. We know the rate of change. It was given in the question. So that's easy enough. So that means that our final equation is 20 cents times how many kilometers we go. All right. We would have got that from our triangle in our graph here because we went over 300, and in that time frame, we went up we went up, what did we go up here? We would have went up 60. So that means that our rate of change is your y over x. So 60 divided by 300. And there's my 0.2. All right. Okay. So there's D part. And you can get that any way of those. Flipping over. E, what does this relation represent, partial or direct? So partial or direct, we have an initial value, all right? Now I got to circle it another color. So if you have an initial value, then it is a partial variation. So it's a partial variation. Partial variation. Because I'll say it does not go through 0, 0. It does not go through 0, 0. Determine the rental fee for 45 kilometers using the equation. So our equation was y equals 0.2x plus 50. Now, in the question, they gave us a measurement in kilometers. So which, if you can't remember whether it's y or x, you just go back and you see that, I've penned over it so much here, that the number of kilometers is in the x column. So the x value will be kilometers. So that means I can put in y equals 0.2 times 45 plus 50. I'm drawing so big, it doesn't fit. So now I can punch that into my calculator. 0.2 times the 45 plus 50, and we get $59. So therefore, 45 kilometers will cost $59. All right, and then next it says, using the equation, determine the maximum number of kilometers you could drive if you want to keep the cost to $100. So in order to do that, we need to use our equation solving skills. Okay, this is why we went through and we've done solving equations. Cost is the y value. And again, you can check back to your table of values, but I know it is 100 equals 0.2x plus 50. We can solve this because we have worked on our algebra skills. We want to isolate the x term, which means that we need to get rid of the 50. So we will subtract 50 from both sides. So that means that 50 equals 0.2x. So we want to get x by itself. So we're going to divide by 0.2. And we get x equals, so 50 divided by 0.2 is 250 kilometers. So therefore, to stay under 100, under $100, you can only drive 250 kilometers. All right, anything over is going to cost us more than $100. So a couple of reminders here, okay? When you determine the equation of a linear relation, you're always going to have two variables. So I'm looking at this little bubble right here. So you're always going to have y equals rate of change as a number, x plus your initial value. So what that's saying as a reminder is this is going to be a number, this is going to be a number, so you're going to end up with a y and an x term. So you're going to always end up with two variables. If the question asks, I know it says if I ask, but if the question asks to determine an answer using an equation, you have to be given one of the pieces of information, okay? So you're going to be given either the x or y value, and you got to solve for the other. So we have to give you one of them. We can't just say, here you go, with two variables. You need to know one of them. And again, that's why we did solving algebra equations. All right, highlight. You know, this is why we've done all this work up to now solving equations, is so that you can solve for one of the variables. All right, I'm going to wrap this lesson up in the next video, but it should go a little quicker because I've done most of the talking in this one.